Geometry. This lesson is brought to you by Diet Dew. Working from home tonight and just taping the second lesson for you guys. It's on line segments and distance. It shouldn't be very hard. You know that a line, we talked about a line already. It's really got no, you can't measure this because it doesn't have any endpoints, right? It goes on forever. But there's a thing called a line segment where if I take, let's say, A and B, and I literally chop off the rest of the line, that's a line segment, then suddenly I can measure something like that. The way we designate line segments is usually we just say A, B, and we just put a line above them. Okay, that's line segment A, B. If this was 4, then you could say, if you write it like this, it means the distance between A and B equals 4. I guess this would be, we need a unit. Okay, does that make sense? All right. If we say that two lines are congruent, the symbol for that is, it's like an equal sign and then you do a little squiggle on top of it. That means it's congruent to. Congruent just means that a shape has, or a figure has the exact same shape. Doesn't matter if it's spun around or moved or transformed in any way, it's still going to have the exact same size and shape. There's something in geometry called a construction. And this is really a classical thing back from when Euclid worked with geometry as a Greek man. This is not really something I'm going to test you on, how to do a construction, but I think it is worthwhile knowing. Euclid's view of making a construction was that he was always going to have, or sorry, only going to have a straight edge and a compass, and of course something to mark with. But he wasn't going to use a ruler, he wasn't going to measure, he wasn't going to use a protractor, nothing to measure with. So the first construction I want to teach you, which is going to be a fairly simple one, is how to do, how to basically copy a line segment. And I think instead of showing you on the board, I'm going to show you on a piece of paper here. Okay, so I've got line segment AB, and I just want to copy that, basically make an exact copy of that somewhere else on the paper. I'm going to call that one CD. Remember that Euclid says that I'm not going to measure this with a ruler, so I'm just going to use a straight edge, and I'll just put it here, and it doesn't have to be in any direction in particular. I'm just going to put it here. I'm just going to draw a line that's going to be longer than line segment AB. And then all that I do is I take my compass, I put it down here, I'm going to put one end on B, and I'm just going to measure over to A, and I'm going to put that smack dab on A, right there. And then I just simply transfer that over to the line that I just drew, or the line segment I just drew, put that on one end point, and then I just do a little, just a mark there. And so basically I know that that distance, if I remark this now, this is going to be C, and we'll call then D, that the distance between C and D I know is exactly the same as between A and B. Okay, that's your first construction. Okay, last thing that you're going to have to learn is, is how to measure distances of line segments. So if it was a number line, that's going to be fairly simple. Let's just say I have a 0 here, and my number line starts at, let's say, I don't know, -2, and I go up to 3, and I'm going to talk about this line segment here, 2 up to 3, -2 up to 3. Well, you can just see on there and just count, and you can tell that's going to be a distance of 5. If you wanted to be a little more rigid about this, you can take one of them, like 3, subtract the second one, subtract -2, which is going to end up adding it, and then you're going to take the absolute value of that, and you'll get 5. If we do it the other way around, we would get -2 minus 3, which is going to end up being, plus -3, which is going to be -5, and then we take the absolute value of that, and we end up with 5. So the distance is 5 no matter which way you cut it. So on a number line, that should not be a big deal. On a coordinate plane, it's a little more complicated, but not much. So here's a coordinate plane. We got our y-axis, we have our x-axis. And let's say that we have a spot right here, which is going to be 0, 3. And we have a dot here, which is going to be over 4 up 0. And I want to determine the distance here. If you look at that, that's going to make a right triangle. And so that's going to lead us to the Pythagorean theorem, which you remember is a squared plus b squared equals c squared. Well, this distance here, we'll just call a squared. And so by the formula that I just showed you, we're going to subtract the distance here up to the distance here, and we went up 3. So if we, and this was 0, so we do 3 minus 0, we're going to end up with 3. Same reasoning here, we went over 4, so 4 minus 0 is going to be 4. And so you would do, of course, 3 squared plus 4 squared, and that's going to equal c squared. Do this, it's going to be 9 plus 16, which is going to be 25. If you want to figure out c squared and figure out what c is, you take the square root of that, take the square root of that, and it's going to be 5. Since we're measuring distances, it's always going to be the positive number. A little more rigid formula the book shows you. For your y value here, it would be y2, which is 3, minus the first y. Or we could do it the other way around, it doesn't matter. Square root of that. I mean, not the square root, the absolute value of that. And you're going to square it. And then your x value here, we would do x2 minus x1, absolute value of that. And that's going to equal c squared. So since we want c, we're going to take the square root of this side and the square root of this side. Is that showing up on the camera? I hope so. Now, we really don't need to worry about the absolute value now. Oops. Because you see that we're squaring both things. So even if those were negative terms, once we square them, they're going to be positive anyway. So I'm just going to rewrite this as the square root of y2 minus y1 plus x2 minus x1. And that's going to equal our distance that we're looking for here, this diagonal. Try that out, and I'm sure you'll see that it works. Okay, I think that is all there is in this section. So that'll be all for tonight. Cheers.